Okay, so now this is part 2 from example 5.1. So we are now at question D. Okay, at D. So we have to determine the depth and specific energy immediately upstream of the sluice gate. So we have a ridge with the slope of 0.03. No, the slope is 0.05. Okay. In somewhere at the upstream, you have a gate, and it's given that the distance of this between the gate to the bottom of the channel is equals to 0. This is y gate. Okay, y gate is equals to 0.5 meter. So the question wants us to find the depth and specific energy immediately upstream of the sluice gate. So we want to find the energy and depth immediately upstream of the sluice gate here. Okay, so in this case, in the case of sluice gate, we have learned before that energy is conserved, right? Energy is conserved. So when energy is conserved, so energy at sluice gate is equals to energy at the gate. Okay. So we can just find the energy at the gate then. So energy at the gate, we will use Y, the depth below the gate. So this is Y gate plus Q to the power of 2 divided by 2G Y gate to the power of 2. Okay, so we have all the information, so we can find the values. 0.5 plus 3 to the power of 2 and divide by 2 times 9.81 times 0.5 to the power of 2. So the answer will be 2.33 meter. So from this answer, you can say that since energy is conserved, E gate is equals to E at sluice, so it's equals to 2.33 meter. Okay, so since energy is conserved, you know that you will have alternative depth. Alternative depth. So the formula for calculating alternative depth is not something new for you. You can search from the previous video and also from the textbook. I think from chapter 2. Okay, so alternative depth, ALT, I put it like this, is equals to 2 Y gate divided by -1 plus square root of 1 plus 8G Y gate to the power of 3 divided by Q2 to the power of 2. So you solve this question and you can get the answer as 2.24 meter. Okay, so now you know that the energy just before the sluice gate is equals to 2.33, and then the height is 2.24. Okay, let's continue with the next question. Okay, but first maybe it's helpful if you can write the depth here. This is as 2.24, so y in E is 2.33 meter. Okay, now we continue to the next question, which is E. If there is a hydraulic jump, determine the depth on both sides of the jump. Okay, what do you understand about hydraulic jump? In hydraulic jump, we know that we conserve momentum, right? So, okay, let's find it. But before that, let's erase the answer for question E or D. Sorry, this is the answer for question D. Yeah. Okay, so let's erase this because we are going to answer the next question. So it's taking so much time to erase all this. It's just the same like when we are doing face-to-face class, where I have also to rub off the whiteboard. Okay, so let's answer question C. Sorry, E. It's about hydraulic jump. Okay, we know earlier that we have the normal depth here, right? It's given y normal is 1.26 meter. Okay, so here we know that the y gate is 0.5. Okay, so to answer this question, we know that we have to, if there is a hydraulic jump, the flow will be like this. This is hydraulic jump, and then it comes back to subcritical flow, right? Subcritical flow, in this case, y normal is given as 1.26. Okay, we know immediately below the gate that the height is 0.5 here. Okay, but we do not know here. This is where the conjugate depth occurs, y conjugate. So we do not know here. But we know that after the jump, we have y naught. So in this case, we can find y conjugate using the value of normal depth using the concept of momentum conservation. Okay, so please look at the notes of momentum equation if you cannot recall about that theory. So basically, it's given from the formula that if you have this situation, so y conjugate is equals to y naught over 2, because in this case y conjugate is between this and this. Okay, the conjugate depth. Okay, so this is the formula. 1 plus 8q to the power of 2 g y naught to the power of 3 minus 1. So you put the values here. You know that q is 3, and you know that y naught is 1.26. So you just put all the values in this formula and you'll find the conjugate depth as 0.6. 0.73 meter. So where is conjugate? Y conjugate? So it's here. Okay. So previously we found, okay, we know that y gate is 0.5, and we know as it goes along here before the hydraulic jump. Okay, this is the hydraulic jump, and then the hydraulic jump the flow will go back to normal depth. So here we have the conjugate, y conjugate, which is equals to 0.73. Okay, so do you know where is critical depth? So critical depth, well, we calculated critical depth. So please look at the previous, the part 1 video. The critical depth calculated was 0.97. Okay, so we have YC, which is equals to 0.97 meter. Okay, so 0.97 meter is somewhere above the Y conjugate. So it follows the slope of the channel. Okay. Okay, so this is YC, critical depth, is equals to 0.97 meter. Okay, so I think we can already know the profile of this section. Okay, this section here. Okay, we want to know this profile. So it's going up, right? But we want to know what kind of ridge is that. So we know that YC, Y critical depth, is 0.97 meter. And okay, now when I'm talking about the flow profile here, we are already at question E. Yeah, this is already question E, because all these things about the depth, the conjugate depth, this is question D. Sorry, this is not question E. This is E, and actually this is F. Okay, this is question E, because you want to find the conjugate depth, and this is F, the profile. So the question actually also wants us to find the energy. So in this case, the energy at that point is equals to Oh no, sorry. The question only wants us to find the depth on both sides of the jump. Okay, sorry. So let's move on to question F. Sketch any flow profile that exists. Like I said just now, so this is the profile that we want to know. So if you want to know the profile, you must know YC, and you know that the flow profile, the Y here is below than Y critical. So the profile how that exists. Okay, I'm looking at my notes. Okay, so since YC and Y, so we are comparing actually here the Y conjugate and Y critical. So Y conjugate was 0.73. So since Y conjugate is less than YC, so if you refer from figure 5.3, then you will know that this is M, mile reach, and mile reach number 3. Okay, so let's stop the video now. I will continue in the next video. Okay.